Good morning and welcome to the session. We are basically going to understand the MLOps concepts, which is the most trending topic, I should say, in the industry right now. And obviously, it becomes very, very important for whatever the work that the team is doing is actually consumed by the end users. And unfortunately, data scientists who are not programmers, they're not software developers, right? So they do not know how to ensure that the machine learning models that they are developing are given to the end users. I mean, the consumption is something that software development team should take care of. But again, if the software development team has to work on deploying or integrating the solution that is developed, which is machine learning models, the software development team should also understand what application that they are deploying, how the application is developed, what are the finer aspects of the development, the life cycle of this entire product development. Because when they are integrating, they also need to ensure that there is continuous integration and continuous development. This is the one primary key aspect that we need to look at when we are talking about productionizing any solution. So software developers are going to focus on this aspect, and for that, software developers should know what does machine learning is all about. So there are two different teams, you can say, two different entities or two different worlds, and without understanding how these two worlds work, we will not be able to effectively productionize the solution. So this is where culmination of both these capabilities are coming together. We are talking about machine learning and we are talking about operationalizing the solution. So we are bringing this together and we are basically calling this as MLOps. So MLOps engineers are expected to understand data science and machine learning concepts, the machine learning development lifecycle, and various aspects of the development of machine learning model. Plus, they need to also understand the capabilities of how a solution can be operationalized. And when we talk about operationalizing, this is the gray area for majority of the data scientists or data analysts, people who work with data. This is the gray area for us. We will not be learning everything under development aspects, but the most important things that we need to consider for deploying is something that we are going to cover. And here, when we talk about operationalizing, we always need to look at two different things. This is a software that we need to ensure that the end users can start using it, right? So this is a software piece of code. This piece of code has to be integrated in an environment with where already some of the applications are running. So this is like your hardware, assume. These are your computers, right? Servers, basically. And on the servers, there are many softwares which are already up and running. Now, when you're bringing in a new piece, this machine learning code, you're basically putting it here. So you need to understand what softwares it has to work with so that the functionality does not break. How do you integrate it, right? So integration with respect to other software solutions that are already available. That is one thing we need to look at. And we also have to talk about the hardware on which the solution is getting deployed, right? This part. Because again, it depends on what kind of solution we have developed here, what kind of data it is working on, and what is the kind of usage, right? This ML model will see. And we'll also have to project the usage, right? We have to forecast the demand for this particular functionality. And based on that, we have to design the integration, design the hardware so that there is scalability. So all these aspects have to be considered when we are planning for deployment. So this is the logic that we are going to learn as part of this particular course. Crisp MLQ. This is our development life cycle, the process that we have to follow. And this contains 6 phases. This development life cycle contains 6 phases. Like any product development life cycle, there's no difference. It's just that we are doing machine learning development. That's all. So let's start with the first one. We say business and data understanding. This is where we do planning, we gather the requirements, we try to understand what is the business problem, what is the scope of the business problem, what are the primary objectives that we have to solve, what challenges we will probably have, what data we are going to work with, where is the data coming from, how is the data collected, right? All this information is gathered and we are doing planning. Right? Planning phase. Post this, we do data pre-processing, dressing. You can say you're basically doing first aid, you're doing dressing to your data. Because raw data would be in different formats. It comes from different platforms, different sources. It is generated using different standards. So it's like a mix of many things. But we cannot obviously work on this heterogeneous kind of data. So we need to try and bring in some order into it. And that's where data pre-processing is done. And this is basically done by data engineers predominantly, or we have data analysts, or we also basically do this, right? I mean, basically this is done by data scientists also. All right. Predominantly data engineers because they develop the data pipelines. Post this, we would have our machine learning experts coming into the picture. Basically, this is where machine learning models will be developed. Or I would probably just say model development. Or even better, I will not use development, I will say model training. I would split this third step, right? This is where you have data scientists, or you say machine learning engineers. I would further split this into tuning as well, model training and tuning. This is an iterative process. We will have to keep repeating this one: model train, tune, train, tune, train, tune. This is where you do refinement. Refine your model for better performances. How do you measure? What are those performance metrics and all that? We're not getting into the finer details of that, but as experts, you already know, right? Hyperparameter tuning comes into the picture. We do train validation, cross validations, automatic hyperparameter tuning. All those things will come into the picture and we'll try to define the best model. This is where we evaluate the model. Once you define that, hey, this is my model, which I want to try and evaluate so that it can be productionized, then you will again try to use certain metrics and evaluate. Check for its general application acceptability. This is how you have to see. What if new data comes in? What if noise data comes in? What if concurrently multiple people are using the same solution? What if it has to be deployed onto a cloud? What if it has to be working on local premise? So various things we will evaluate, not just the accuracy or the acceptability metrics. Post this comes the deployment, and this is where your role comes in as MLOps engineers. Previously, we used to have DevOps people doing this job, or you can say software development team. Okay, so these were basically performed. These steps were previously performed by software development team. Then we have DevOps teams. Then we have finally MLOps teams. Now this is basically the development. This is where the development ends. You're giving the solution to your end users, and your end users start using the solution. But when we talk about the production environment, you don't know what kind of practical challenges you will encounter. It's an unknown territory. We don't know what could happen in future, right? So what we need to do is support the development, right? And this support does not come from MLOps team alone. It is basically the entire team's support, or the entire teams which are involved in development of this machine learning till stage 5. Whoever is involved, all of them as a team have to support the development. It's like your warranty period, right? You give the support to your products or services that you're getting. So that is monitoring and maintenance, right? I would say support for the product. So these are the 6 phases of a machine learning model development. Now, how many of you actually know what was the previous development lifecycle standards that were followed? This is the current one. CRISP MLQ is the current one. But what was the previous one? This also contains 6 phases. Okay, I'll basically write it here. This also has 6 phases. And these 6 phases are like this. I'll write. The first one is business understanding. The second one was data understanding. You can see this is where the first difference is. Right? Business understanding and data understanding both are there in the single step, whereas here these 2 are separate steps. Data pre-processing. Then we have model training. Again, the tuning part would be sub part. Then the 5th step would be model evaluation. And then 6th would be deploy. Okay. So these are basically the differences. Now, why do you think CRISP DM had to be upgraded to CRISP MLQ? What was the primary requirement? Why do you think this upgrade was needed? Anyone? So 2 answers, which I basically gave me the first answer as CI/CD. That's absolutely required, which was not at all considered in these 6 stages. Nowhere that concept is coming here. The next point is after deployment, what? Right? Data drift. Businesses will evolve. Businesses will change. They tend to change. They have to change to survive, either in a positive way or in a negative way. From the development perspective of the business, businesses keep changing. So that means the data that we are getting from these businesses will also change. Now, if data changes, obviously your models will have to change. Model drift will come into the picture. So once you have developed and once you have deployed the solution, it is fine. But how is it going to work on new data? We are not tracking that, right? So monitoring and maintenance had to come in because of this question, data drift question. Another important aspect. In this CRISP DM methodology, there is nowhere we are benchmarking our progress, right? Whether the steps that we are following, whether they are satisfactorily completed or accomplished. Are they meeting the standards? These checks were not there. Quality checks. Right? So you can see specifically we are saying Q in CRISP MLQ, that's another point that is added. So the primary difference, friends, when CRISP DM methodology was followed as a standard process, the focus was only on developing a machine learning model. In this, our focus is develop machine learning model. That's all. Now, why are you developing this machine learning model? Ultimately, it has to be utilized by the end users or the businesses for taking the advantage of the data. But where is that process being actually considered for the ML development? That foresight was not there in this case. So you given sample data, you take sample data, you do all the rigmarole that you'll have to do, follow the steps, develop your machine learning models, right? So I'll say, let me write it like this. I'll simply say y is equals to mx plus c, or y is equals to f of x, more generic. You got a model. You're evaluating it, saying that, hey, it is working very well with respect to the testing data set. And fine, that's all. And you're saying deploy. Depending on the requirement of the customer, you're deploying it on local machine or cloud or whatever that platform is, irrespective of that. You're saying the model is working fine and you're washing off your hands. That's all. You asked me to develop a machine learning model, I developed it and I gave it to you. In fact, I helped you in deployment. That's all. But what is the acceptability of this machine learning model in the business? What if new data comes in? Right? What if the data is changing itself? Right? And this is something that I have seen from my experience. Because of COVID, of course, thanks to COVID, I also realized it much later. So when you basically develop, right? I was working in aviation sector. So in 2018-19, I was in aviation project. We developed many machine learning solutions, big data implementations using open source platforms and all that process happened. It was close to 1 year project. And as part of that, one of the very simple machine learning model that we developed was predicting seat occupancy in routes. Say if a flight is traveling from point A to point B, how many seats will be there? Sales predictions, you can say. In simple terms, I'm basically doing sales prediction. How many seats will be sold? Because depending on that, I can devise my discount offers for the tickets and all those things. Now, this was one of the prediction model that we developed. And this was developed in 2018 and 19. Then you know what happened, right? 2019 December, 2020, COVID stuck. The entire aviation sector got halted. And everything was standstill. Slowly in 2021, the business resumed. Partially. Now, do you think the solution that I have developed here, which was from a historical data, this data was, let's say, from last 5 years, assume 10 years. 2008 to 2018 data was taken, assume. And then we are developing the solution. And this was developed. And it was probably giving me, I don't remember the accuracies, but around 90%. Okay, let's say around 90%. So this was a very good model which was developed and it was being used in the business and everything was happy. 2020, business stopped. 2021, the business resumed. Now tell me, should I be using the same model in 2021? Do you think it will work? It would have worked in the first place. Do you think that?
No.
Right? Absolutely. Because the dynamics of the business can't completely changed. So you cannot expect a model which was developed using this data to work in a business case where the entire dynamics of the business changed, because entire data changed. When I say data changed, probably here you will have sales targeted with respect to X1, X2, probably X20. 20 different features you probably would have captured, correlated. But a lot of these factors or features were not resumed, not considered when the business resumed it. It was not in a full-blown way. So maybe here I would have only 10 factors being considered. So if I have to predict my sales, I cannot use this model because it was developed on 20 features. Here it is only 10 features. Forget about what is the model's accuracy. I cannot, first of all, in the first place, use the same model. This was a practical challenge that we had to address. This was a concern in Crisp DM because we don't care about these drifts when you are developing a machine learning model using Crisp DM. Right? And how do you know 90% would be the best model? I say 90% is what we achieved. But is it acceptable from the business perspective? I don't have any benchmarks. I cannot say that, yes, based on the agreed terms, the solution that we have developed is acceptable or not acceptable. There's no reference anymore. That means quality checks were not implemented. All right. So these practical challenges in deployment of a solution and in usage of that particular solution after deployment as a function had a lot of practical challenges. And that's the reason why we have upgrade in this particular solution. And business and data, they both are tightly coupled. You don't need to do these two steps separately. Because as I mentioned, right, if you are understanding the business, you'll also know what kind of factors you will be using. And if you already know the factors, then you know how business is working. Right? So these are tightly coupled entities. So both of them were joined together in this particular step. Now, when we also have this step added, along with this step, there are many aspects that got added. One of that is your success criteria. The success criteria were not considered in Crisp DM methodology. This point was not there in our initial project plan that we are drafting, the initial project charter that we are drafting. We did not even consider checking on these things. But Crisp MLQ ensures that these are maintained. And when we talk about success criteria, there are certain points that we need to look at. So the first point I would say would be, how is this model benefiting the business economically? From an economy standpoint, how is this business benefiting and what is the expectation of the business? What is the economic success criteria? There are many ways to look at it. One of the ways I would say at a very base level is, if I'm investing $1,000 and if I'm implementing the solution, then what is the benefit that I'm going to get? Right? What is the returns? Basically, we are looking at returns. This is investment. This is the returns. So before this solution implementation and after the solution implementation, how much benefit you are seeing? What is the difference? Is there any net difference? Right? So this is something that we will have to evaluate. And from a business expectations perspective, they would say that, hey, I'm expecting around 10% improvement. So there will be quantified right, ways to justify that 10% is something that is acceptable from expectations, from an expectation standpoint. And we are going to record this. You're saying that the solution should benefit the business by 10% in revenue. And after the solution development, after we basically give the entire solution to the business, we are going to compare, of course, with the help of client, of course. So we are going to keep checking for a stipulated time and observe the differences, see the differences. Is the solution actually helping the business to improve their revenue by 10%? If not, can we find some other solution? Go back to the drawing board and try to tune your model so that it actually improves the end line. Okay, first check. The second check. What is that you're solving? What is the business problem that you are solving? So here, the business problem in the aviation example, if I talk about, I wanted to ensure that maximum seat occupancy with me, right? Maximize, I would not, I mean, we are generalizing it, right? So maximize. Say, for example, in a particular route, point A to point B, always 80% of the seats are only occupied. So when I try to predict the seat occupancy, then whatever the solution that we are prescribing should allow the seat occupancy to improve. Maybe you're targeting 90%. So we're not having any benchmark. Some other route, probably from P to Q, the seat occupancy would be 90%. So you want to improve this to 95%. Maybe. So the solution has to be, in general, helping the seat occupancy rate to increase. So that's your maximize the seat occupancy or sales by maybe 2%. This is the target that your business wants to achieve. So again, once the solution is developed, you are seeing whether the prescription that you have given, the prescribed solution that you have given based on the machine learning models predictions, you are going to observe whether the overall seat occupancy is improved by 2% or not. If not, again, you go back, right? So these are the quality checks that we are going to look at. From a machine learning model development perspective, we are going to look at another point. I'm writing it here. This is machine learning model success criteria. So as a machine learning expert, you'll basically look into the business case. You'll be looking into the data case. You'll be trying to look at what kind of variations in the data are seen and all that. And you're going to say that, hey, I will try to achieve a model for predictions that we're doing, which could be around, let's say, 92% accuracy. So you set a benchmark for yourself saying that the model that we are going to target and develop should reach 92% accuracy. So for that, you are going to do a lot of rigmarole hyperparameter tuning. You probably use AutoML techniques or manual ML techniques, try different machine learning models, try doing a lot of pre-processing, feature engineering, etc. But ultimately, you'll have to achieve this. Until your model reaches this 92% accuracy benchmark, you keep experimenting. So these are your 3 major success criteria points that you will have to define upfront at this stage. Benchmarks, and all these are theoretical, of course. You are going to talk about these things with respect to your management, the client. And then you benchmark these things. Once these benchmarks are defined, as part of your planning stage, then you know what are your targets that you are going to meet or try to achieve. Now, the next stages begin. Your data collection does begin. Primary, secondary data points are there. Whatever the data that you or feel are relevant, you'll have to capture that from whatever sources that you're getting. And remember one thing, business is not stopping. From a machine learning model development perspective, you're only taking sample data. You'll only talk about sample data, right? You'll not really worry about continuous flow of the data. Whatever the maximum sample data that you can capture, you're going to take that as an offline data. One chunk of data, you take it. And then you proceed further. But in CRISP MLQ with MLOps standards, you're going to say that this is my source. And the data keeps getting generated into the source. It keeps coming in because business is continuously working on, right? It's running. So you are going to take different chunks of data as different versions. At this point, till this point, whatever the data that you can capture or achieve, take that chunk of data and call data version 1. All right. And using this version 1, you will proceed with your development and all that. And while you're evaluating, you probably will look into data version 2, 3, 4, etc. And then you're going to compare excuse me, on how your machine learning model works on these different new versions that are coming. You probably would have seen the development lifecycle image. If you're using, MLOps, without MLOps, how your machine learning model is developed is given here. So we are taking sample data, data store is there, whatever raw data that is available, we take that, pre-process it, we do EDA, data analysis, data pre-processing, etc. And then we build the model. And for building the model, we implement the split strategy. We evaluate it, we validate it. There should be a dotted line here. We refine it and all that. And then once the benchmarks are reached with respect to the accuracy, we put that in a code repository. This code repository could be your GitHub or kind of GitHub related code repository softwares where your data and code is getting dumped because multiple contributors will be there. So from all these developers, you're getting the final code here. Then comes your software team, software development team, which basically takes that model, deploys it. And as the end users start using the functionality, they generate a lot of new data. The model is generating the results data. All that would be again stored back into the data store so that we can do the performance metrics, basically the comparisons and all that. So this is without MLOps principles being followed. Because your data does not stop here, right? New data keeps coming in. You are taking one version of data, one set of data, for example, 1 month's data. Isn't it? Say, for example, if I talk about 360DigiTMG, which was a tech company. Let's say we are trying to do some kind of analysis on 360DigiTMG's data. Students inflow, let's assume, right? Number of students enrolling a program. Now I will take November month's data, or I would say 1 year data. So from November 2021 to November 2022 till today, I'm going to capture 1 year data. I will develop a machine learning model and I will predict my label data, target data. Right? Now the question is 360DigiTMG stopping the business in November 2022? No, right? Business continues. What will happen in 2022 December. There will be new data coming in. Okay, you're saying yes, 2022 December is new data. I'm going to do predictions. Right? I'm trying to do predictions on that data. Fine, you are doing predictions, but December is completely different month, holiday season. Or there will be some other competitors in the business, or there could be some new programs launched by 360DigiTMG, which probably will have a lot of attraction, right? A lot of traction from the students. So we never know. Business is very, very dynamic. So your predictions go wrong if you see new changes coming in, because you're capturing the pattern in the data for last 1 year data only. The new things were not recorded. Anyways, you are doing predictions, but those predictions are completely wrong. Fine, this is a learning because we have launched a new program. Predictions are going wrong. But what about the model that you have developed here? Don't you think that model has to also update itself? It also has to learn new things, right? Because you're saying December, the pattern was different. So if I have to use the same model to predict in January 2023, don't you think this information becomes very critical for the model to understand how the business changed or evolved? So what should I do in this case? Should I retrain the entire machine learning model again? So in this particular flow, you can see that CI/CD is not. And when we talk about machine learning models, continuous training, CT, is important. Right? So that aspect is not there. So we are going to dismantle this entire machine learning model and reiterating the entire step, the process. It's like new project altogether now. So this time I will include 2022 data as well from the raw source of the data. Again, follow this flow and develop the model, store that in code repository, then deploy it. Now, again, in January 2023, new data comes in, you do the predictions and all that, but business will also be different. You're not a god to get 100% accurate model. Businesses will change. So those changes, again, which are there in January 2023, should be taught to machine learning model so that it can be used for predicting better results in 2023. So this flow is missing. Now, if I talk about with MLOps strategies, that is your continuous integration and continuous delivery, these two stages are being tightly coupled. In this, there are two different stages you can see. The dotted line that you're seeing here is separating machine learning model development. Whereas in this stage, we are talking about deployment. Software team comes into the picture. So this is a different team. This is a different team. Two different disjoint units are working. Whereas here in MLOps strategies, you don't have disjoint teams. These two basically are going to be the same teams. It's like a single team working together. These are not separated entities. Okay, so you'll have a single store where for data analysis, you're recording the data and you select the model, data pre-process, select the model, pre-process. This part is your anyways model development. Here, automated techniques have come in. Then you're modularizing your code. When you talk about modularizing code, we are generalizing the code flow using pipeline concept. That means any new data comes in has to go through these series of steps that we are defining. Right? Pipelines have to be built so that you're not hard coding the code on the data. Now, once you're modularizing the code using pipelines, you dump that in the repository, GitHub repository. And of course, even when the software development team is trying to consume it, it has to test, right? So you're going to help them to test the pipelines that are developed, right? And all of this is considered as a single package software. So this becomes your package store. This is your final code. It's like a package now. If everybody is familiar with Python, right? So you know how packages are actually used. They are reused. Irrespective of data, they are reused. So we are going to ensure that the entire development is more like generalized, as if it is a function package. These packaged pipelines will be deployed. So irrespective of whatever the data is, the solution should work, right? And once this is developed, you can see again the training pipeline is there. So irrespective of whatever is the data, the same steps will be done automatically. The final model will be registered, and this final model will be used for servicing the end users. The functionality will be used. So you can see here, this step after deployment, we are not using the trained model. We're using the pipelined model or package, so that when new data is also coming in, you will have the entire flow, this flow implemented here. So this is for experimenting and identifying what are the best sequence of steps. This is your training process. Then your modularization of the code happens, where we are trying to generalize this flow and test that flow, and then generalize it as if it is a package for reusability. That reusability code will be deployed. So you probably have developed this using data till November 2022. So this is till point today. You developed the code, right? And you designed a pipeline model, and you are deploying that. Now, let's say this model has to be used for predicting Feb 2023 data. Now, in the previous case, the model would have been a model which was trained on November 2022. But now what is happening is there is no fixed model. You're not fixing the model, trained model here. You're fixing the steps. So all the data till January 2023 will be used here for model development and registry. The final model which is developed on Jan 2023 will be used here, right? And we are anyways consuming this data, restoring, saving all the data, and then putting that in the data store. You understood the difference, guys? Any questions in this? As part of today's discussion, we compared the differences between CRISP MLQ and CRISP DM. This is the standard process or development lifecycle steps that we follow for implementation of a machine learning model. The primary difference between these two is quality checks. The second step would be continuous integration and continuous development. The third step is monitoring or support, you can say, right? So monitoring and maintenance. This is basically for supporting of your model once the solution is productionized, because data drift happens and there will be definitely a skew in the model's performance. So that aspect is not being captured. And we discussed about how these aspects are implemented, and these implementations basically are by following MLOps standards. When I say MLOps standards, it's basically considering the productionizing aspect, right? Considering how you want to implement your model, and after deployment, what are the various steps that you'll have to consider. Those aspects were actually considered when the model is basically being developed. From the initial stages, we will have to keep these points in mind for your development. And we have seen how the flow varies when you're developing your model without or with machine learning operation standards. And here, the most important thing that we need to look at is, rather than saving the trained model for deployment, we will have to save the pipeline, the flow, the sequence of steps that we need to implement. This is to ensure that the model is automatically retraining and upskilling itself for continuous integration and continuous development. So pipeline concept comes into the picture, and these pipelines are basically coming into the picture for CI/CD. And here we are also talking about the packaging. So your code should be packaged so that you can reuse it, irrespective of the data that you are actually flowing into the system. Pipeline is nothing but the sequence of steps that we are basically trying to apply on your model development, on your different data. Excuse me. So these are the primary differences that we have looked at, and the keywords that you need to remember from all these discussion points is code repository, the flow, that is your machine learning model development lifecycle steps, that is CRISP-MLQ, retraining, CI/CD. We also have to talk about packaging, and what else? Okay, these are some of the things that I can immediately think of. These are all new terminologies, right? Success criteria, quality. These are all new terminologies that we will have to now consider from a machine learning model implementation perspective. So if you are a machine learning engineer, ML engineer, these are all new terminologies for you. And in order to implement these steps, right? So when I say these steps, we are trying to follow. Where is this? Yeah, this one. In order to implement this flow, we need certain tools, because when you're trying to develop a machine learning model, we generally use very basic Python code and all that. But designing this flow in Python becomes very cumbersome project in itself. So we need certain tools or standards which allow us to follow this flow. And those tools are nothing but your MLOps tools. So a lot of companies are coming up with automated steps for doing all this implementation. And there are two, again, important aspects, friends. From a machine learning terminology perspective, I'll try and explain it. A machine learning model development is very much depending on data. Right? Everything is depending on data. And using this data, we train the model. Right? And this becomes your ML model. So retraining will give you probably different results. Updating your data will again give you different results. So this is basically the flow. So in this particular MLOps standards, you will have to look at how the training process is varying with respect to data. So you'll have to focus on data. And after training, you'll get ML model. How those ML models are varying. So these are two things that you'll have to keep a check on. So from this perspective, you will have data validation, data versioning, data feature engineering, EDA, right? All these aspects come into this picture, which are basically allowing us to monitor the drift in data, changes in data. With respect to models, retrained models versions, right? There could be a number of different versions. So whatever is registered for your final usage, those models will be compared. This is basically the model drift perspective. So model registry will also be there, which is again automatically your models will, the tools will register these models and then try to do the comparison. So once you are having these data batch versions maintained and the models versions maintained, you will be able to generate reports and do the comparison. Okay, this will capture us with respect to the drifts in the models and drifts in the data. All right, so how do we do this is basically something that we need to understand. And you can see here, these are all the cloud-based points, cloud-based readily available tools, MLOps products points. These are GUI based, very easy. No code or minimal code is required, and everything is controlled by a single platform. Easy. You'll be able to monitor, track from a user perspective as and how the development happens. You'll be able to track all of them, look at the logs and everything. The disadvantages, though, are they're costly. Though we are saying it is costly, but I would always look the expense part from a business perspective. This is also something that you'll have to think from influencing your management in adopting these readily available tools. If you want to develop a machine learning model, friends, what do you need? You need data. You need the infrastructure for developing the models. This is going to cost you, but most importantly, you need ML engineers, data scientists, data analysts, resources. Right? This is also one of the resources that you need. So what you do? From a management perspective, you hire the team, pay them the salaries and ask them to develop. So maybe there are 5 members, 5 team members, and they are taking 30 days to develop the machine learning solution. Right? So for each of them, you are going to pay salaries and then, you're going to wait. The advantage that you're going to get from these MLOps readily available tools is that you probably will have one resource and you will be able to develop everything in 5 days. So if you compare the cost associated with this and this, you would, from a management perspective, always inclined to choose this one because time is always going to be the most important, crucial aspect over your commercial aspect, right? Money aspect, because time is money. So if you do cost-based analysis from the project to project, right, end project, you would be always tempted to choose these readily available tools, and that's where the industry is slowly getting inclined towards. Right? So it is expensive from a usage perspective, but overall, this is always going to be more effective. The other disadvantage you have is if you want to use these end-to-end readily available MLOps products or tools, you cannot do a lot of customization. Right? And if the solutions are designed to consume more resources with respect to hardware or software, then you need to, right? So additional resources might be required, like your cluster-based application, multiple resources, multiple VMs have to be used, right? Or data read-write operations are happening. So there might be certain points which are out of your control, because this vendor locking will be there, right? They're designed like that. That's all. You cannot, if you want to use them, use it. Otherwise, choose other option. So these are probably the primary two disadvantages that you will see rather than expense. There might be certain scenarios, certain projects where time is not a crucial aspect. It's a core development. Probably you're talking about developing a solution from scratch. You have ample time. In such case, yes, this becomes a crucial aspect. Expense, usage of these readily available solutions. From that perspective, you'll always try and look out for open source options. These tools will allow you to implement MLOps standards, but without any additional cost of using these tools itself. It all started from containerization concept. You have Docker, you have Kubernetes, you have MLflow, Kubeflow, and TFX. These are the modules that we will be covering. We'll be looking at Docker, then Kubernetes, then we will try and see whichever, right, is this next among this. Kubeflow is, at least for me, is a tool which is a proper end-to-end scalable solution. And for that, of course, you need a lot of resources. It cannot be implemented on your local machine. So from an implementation perspective, from its usage perspective, it has a lot of flexibility, a lot of, I should say modularity. But at the same time, it is costly. From a resource perspective. And these are simple solutions. TFX is a Google product again. All of these are Google products. Okay? Everything that we are looking at here is probably directly or indirectly is thanks to Google's research. Okay, Kubernetes, of course, is a Google product which relies on Docker. Docker is not a Google product, but it uses Google product uses Docker. TFX is basically an extension to TensorFlow library itself that Google has developed, and the team is trying to implement the entire MLOps standards for that library, TFX TensorFlow library, so that just using this one library, we can implement everything end to end. And here we will also look at something called as Beam, Apache Beam. And we'll also use this workflow orchestration tool called Apache Workflow. And so these are basic. This is probably used more by data engineers to schedule and trigger the pipelines. Rather than directly used by machine learning implementation, machine learning operations team. Yeah, but it is an orchestration team tool, sorry. So we'll also try and look at what exactly Airflow does. You can see this is like a bonus. So these are the tools that we will be covering. And all of these are open source, at least from a software perspective, all of them are open source tools. Hardware, of course, you will have to procure hardware, and that's where the cost is coming into the picture. As an organization, you can probably use an open source, single local premise servers, a single server or multiple servers, or you can have a distributed environment setup on premise, that's Hadoop cluster setup, or you can use cloud-based platforms for infrastructure perspective. Right? Not the software perspective, but from hardware perspective, you'll at least try to use the cloud platforms. And that's what you're going to use. So be ready to shell out some money for implementing open source tools also. But that is how it is. That's how we have to learn. We cannot bring in a on-premise cluster setup because that includes a lot of laborious jobs, a lot of network related aspects, a lot of infrastructure procurement challenges, and all those things will come into picture. So businesses look at all these things, and rather than having an on-premise server procured and maintained, very simply hire your hardware from cloud platforms, right? So that's another advantage that we will get from cloud platform usages. All right, so this is basically our flow. Now, whenever we are talking about development, I'm not talking about machine learning development. I'm talking about any application development. Okay, it could be any app development. These are basically some of the important aspects that we look at after the development happens. After the development, okay? You will probably be developing multiple versions. So you will have to track these developments. Let's say today you are going to say that, hey, this is the best model I've developed. Tomorrow, one of your team member probably will relook at and tries to change a hyperparameter, and probably he cracks and says that, hey, I got a model which is giving better results than yours. So that becomes another version. So you will have to record all these versions so that you can also do the comparison, and you don't have to manually do it. You can use your code repository softwares like GitHub, GitLab. There are many solutions are there. GitHub is probably the most popular one. Gitbucket, right? All those things are there. So you can use GitHub, which will automatically do the version control for you. Once, let's say, one of the version is selected. In your application, there will be multiple modules, multiple features, you can say. Right? Modules are features. When you are trying to consume this application, unit testing has to be done. Unit testing is basically taking each of those features and then checking whether those features are working or not. Now, once unit testing, individually all the modules are working, how about cross-functionality issues? If I'm using all of them together, then do you see any flow breaks, integration issues? And all those things will be checked here in the integration testing. Now, once the integration testing is also success, right, that there is no flow issues, everything is working appropriately well. All of these individual components are integrated together and giving us the results. How are these results? Are these acceptable results? Right? That is basically the acceptance testing we will have to do. Right? Whether they are matching the company's expectations or not. And once this acceptance testing is satisfactorily completed to the company's expectations, then we will implement that on the test environment, and we are going to check whether after integrating it, after basically bringing everything together and deploying it on an environment on some server, is it working well or not? So if everything works well, then we take it to the production environment. So first, in fact, from a development scenario, you will have dev server, then you will have test server, and then you will have production server. So from here to here, these are the steps that we will have to look at. In fact, in this also, we will do all these individual checks as well. Once it is working here fine, then we do take it to the production. We replicate whatever things we have done here. We basically do multiple test server implementations. We'll also record the steps, and we'll just replicate those steps on the production server. This is how the deployment should actually be done for any application. Okay, ML application is not so different. All right, so this is basically the steps. Now, I will talk about, probably will not have enough time to discuss everything, but when we talk about the tools, automated tools, the auto ML features is what we are going to talk about. all the major cloud platforms, including Ali Cloud, Oracle Cloud, IBM Cloud, right? Whatever you name it. Machine learning services are available on the cloud platforms. And I'm saying service, right? It is available as a service. So you register for the service, you register for that module, ML module, then use it. When I say use it, we are basically saying that the sequence of steps are readily available. The pipelines are readily available for us. Irrespective of what data you are using, you will be able to use these services, irrespective of what domain you are trying to come up with or you're working in, and irrespective of what solution you are trying to predict, whether it is a continuous value prediction, whether it is a binary classification, whether it's a multi-class predictions, right? So whatever is your target variable, you will be able to use the service. So irrespective of the domain, irrespective of the business requirements from a prediction perspective, and irrespective of the data that we are working with, these ML solutions can be used as a service. So we are generalizing it, right? So on cloud, we will be able to do this, irrespective of whether you are a data scientist or not. And these tools will automatically deploy your solution and give you an endpoint. Right? So you don't have to, again, do a lot of rigmarole in deploying your solutions. You don't need to bring in multiple things into picture. In fact, we will do this. How many of you are familiar with AWS SageMaker? Here we talk about SageMaker. Right? This is basically a feature from Autopilot. This is the service, which is AutoML service in AWS. We call this product as SageMaker, SageMaker Studio. How many of you are familiar with this? And we also have AutoML Studio, machine learning, Azure Machine Learning Studio, I should say. That's the name. Azure Machine Learning Services. And in GCP, the name is now Vertex. Previously, it used to be called as AutoML only, but now it is called as Vertex AI. You are familiar with it, right? Okay, wonderful. So these are the platforms, friends. These are the tools which follows MLOps standards, right? You'll not feel any difference. You'll not see any difference. Basically, what you do is you open the service, load the data, trigger or initiate the training process, and it does everything. You'll get the best model and you'll say deploy. That's all. 3 steps. But it entire process follows MLOps standards. So you will be able to monitor the data drift. You will be able to monitor the model drift. So that means CI/CD implementations are automatically done. You don't have to worry on these platforms. All right. And when we talk about pipelines in these platforms, what we will be doing is we're looking at from a very simple pipeline flow or data architectures. We will talk about the standard storage. These platforms have cloud storage. For AWS, we call it as S3. For Azure, we probably have blob storage or data storage. GCP, we call it as cloud storage, GCS. So these are cloud storage platforms where data will be dumped. And from here, the ML models will pick up your data and then get trained. And then these gives us the best models. This model will be deployed on an endpoint. This endpoint can be used by end user. Okay, so this will be the flow that we will be implementing. We can also connect with various data sources. It could be a database. Again, these databases could be on local premise or on cloud platforms. It could be an IoT devices. It could be the web scraping code that you are doing. So there are data engineering pipeline standards maintained by these cloud platforms. And then the connectivity can happen, and then the remaining flow is as is. Rather than just cloud storage, you can have any data storage or any data source. All right. So this is about cloud platforms, and I'm assuming you people have the cloud platform accounts. If you do not have it, then create them. And I would recommend, if you do not have them created, create them on Friday. Not today, on Friday. If you don't have accounts, right? For new accounts, create them on Friday. Okay, and we will not be giving any access here, student access. Unfortunately, we don't have any. I know you people are coming from ISB background. Some of you are coming from ISB standards. So ISB does have the student accounts and all those things. Probably you can have that experience of having the right student access, limited access and all that. But I would recommend probably you have to create your own accounts and use the free trial period that we are going to get from these cloud access to learn. And also be ready to shell out some money, because we will be consuming some of the resources which require us to pay. But I would also at the same time caution you to ensure that we set up budget restrictions, budget alerts. From IAM, identity access management, I'll show you. And all the three platforms, any cloud platform you talk about, IAM would be one of the crucial service that we will have to look at. And these budget restriction alerts will at least tell us that we are crossing our limit when consuming these services, and thereby appropriately we can take decisions. There will be certain cases where we forget what services we are consuming, and we tend to forget and we don't even log into the system. So in such cases, the billing will be like skyrocketing. Hence, these budgetary restrictions will allow us to at least keep a track. Okay, tracking is very important from your budget perspective, billing.